If you work in this industry as a web developer, you have probably used Figma once or twice in your career. And while you and your dev team seamlessly use it to drag around boxes, you might not have actually thought about how much traffic does Figma actually support under the hood. If you go and ask how many monthly active users does Figma have, Perplexity will give you 13 million monthly active users. So that's a lot of users all opening their own documents, which also means they probably have quite a lot of requests per second they need to handle. Now, luckily for us, Figma actually has a blog post that walks through how their multiplayer technology is set up behind the scenes and what they need to do to achieve this type of scaling. Now, this is a pretty long article, so I'm not going to read through the whole thing, but I did want to point out one of the important pieces, and that is where they basically set up separate processes to handle each multiplayer document, where everyone editing that document will connect to. So in this video, we're going to be talking about something called a stateful router, so that everyone who tries to connect to a particular document will always get routed to the same machine, which will handle this request in isolation. So before I dive into explaining how Figma achieves their scalability using stateful routing, I want to talk about a common approach that you probably have learned about or heard about called stateless routing. So basically, if there's a user and they want to access your API or WebSocket server, you can have them directly connect to the WebSocket server, but at a certain scale, this will no longer work because you have to create multiple WebSocket servers, like a WebSocket A and a WebSocket B. And then in front of that, you're probably going to end up adding some type of load balancer. And then as you know, a load balancer will probably just connect that user to one of these available socket servers. And this approach will take you pretty far in terms of scaling, but again, at Figma's level of scaling, this approach will fall apart. And the reason this falls apart is because a user may be connected to WebSocket server A, but there's another user on WebSocket server B who might be on the same board or the same room who also needs to get that notification or that update. So usually in order to get this notification broadcasted to this user, what you end up doing is adding some type of centralized message broker. Let me say centralized message broker. And you probably heard of Redis. This could be Kafka. This could be RabbitMQ, ActiveMQ. But the idea is that the server itself kind of knows how to forward this message to other people who need to know about it. But all that goes through this centralized message broker. And again, with Figma's 13 million monthly active users, this WebSocket server will eventually just not be able to handle the throughput or messages per second. So again, this was stateless routing. I'm sure you've heard about it. This is typically how we set up our web APIs because it works really well for web APIs. But for WebSocket servers, it doesn't work as well. But luckily, there is a different approach we can do to make sure that we can handle all this traffic, and that's kind of what Figma does behind the scenes. They are using something called stateful routing. So the way Figma kind of handles having all these boards running concurrently is you as a user, when you want to set up a board, let's just go ahead and say create a board. Something in Figma has to track what machine is going to handle the WebSockets that you and your teammates can all talk to on that board. Now at this point, Figma will send back the location that the user needs to connect to. So WebSocket location, and then eventually the user will connect to that WebSocket, which is probably running somewhere else. So I'll say WebSocket process. And this WebSocket process is for the board that you're editing. And we can kind of see this if you load up Figma and go to the network browser. You can see this WebSocket request get made to figma.com/API/multiplayer, and you can see our document ID here. And if you go to messages, I'm going to go ahead and just move around this rectangle, and you'll see all these binary messages get sent over as I'm moving this rectangle on another tab. Okay, so they kind of communicate the movements and the mutations of the board using WebSockets. But the idea with the stateful routing is that everyone who needs to modify this document will get redirected to the same multiplayer room, I guess you could say. So I'll say like multiplayer room. And the reason this type of design is super important to be able to handle the scale that Figma operates in, if you go and check, Figma is able to support up to 500 total participants viewing or editing each document, with a maximum of 200 able to edit simultaneously. So with 500 participants needing to be able to see a document update in real time, and imagine they have 13 million active users, that is a lot of requests per second, and a lot of people all trying to watch this data update live. Now, behind the scenes, it's probably a lot more complicated than this, right? Figma probably has some type of orchestration service, which Figma will contact to tell it to spin up a new WebSocket server if one isn't already running for that particular document ID that they're trying to access, where Figma will basically say, I need a new WebSocket server. And then the orchestration service, whether that's Kubernetes or something custom that they built, will basically spin up or tear down the server. And now with these changes with the orchestration service, I need to kind of reorder how this is happening. So first it'll notify the orchestration service to spin up the WebSocket server, and then it'll create it. And then at some point, the user will get back the new location of that server, which they can then connect to. So if I understand this correctly, this is basically the high level overview of how Figma is able to get all of these users all connected to the same multiplayer room and sharing the board edits in real time with low latency. Now, I will say this is easier said than done. I do believe Figma pays $300,000 every day in operational costs. So unless you have a very experienced team of DevOps engineers, trying to maintain and build this all up yourself in AWS is probably going to cost you not only a lot of money in development costs, but also in just cloud hosting. So having your own fleet of bare metal machines could probably help drive down these operational costs. But again, you'd have to implement that all yourself. So after reading their article and understanding how stateful routing helped them solve their scaling issues, I wanted to build my own prototype to try to implement the same type of pattern. So I'm going to switch tabs to a collaborative board application that I built out, which we can click to create a new board. I can go ahead and just type in web dev Cody. And now on the dashboard, we can go and create a new board that I can invite many people to collaborate with. So I'm going to say testing board, and I'll go ahead and click create. And now behind the scenes, that's going to spin up a separate WebSocket service that's running in its own isolated container. And I'm going to go ahead and grab the share link for this board so I can have someone else connect to it. And now, as you can tell on the left, I can draw a rectangle, and on the right, you'll see that rectangle basically get moved around in real time. This is all using WebSockets under the hood. And the cool thing about this process is that every board is going to spin up in its own isolated container. And then when my users disconnect from the board, they will automatically tear down. Now, like I mentioned, setting up this orchestration service and all the logic to dynamically spin up containers and tear them down when they're not in use is a lot of work, which is why I use a service called Hathora under the hood, which handles all that for you. Basically, Hathora is a server orchestration tool. You can use it for multiplayer games, or you can use it for web applications that have some type of multiplayer functionality, which, by the way, Hathora is a sponsor of this video. And I'm going to log into my Hathora account and go to my collaborative boards app. And I want to show you real quick, every time I spin up a new board, you'll see a new process come online. So let's go over here, back to my dashboard. I'm going to create another board. I'll say testing, and I'll create that one. And you can see it's spinning up a new board that's going to be used by this new user over here, which is pretty awesome. I have all these running WebSocket servers, and the moment I start closing these tabs out, they will be listening for idle connections, and after about a minute or so, this process will automatically get teared down, and you only get charged for when it is running. And if we dive into this container, you can actually get more information about how it all kind of works. We have 0 connected users to this service now. You can see the egress bandwidth, the CPU utilization, and the memory utilization, and you can also see the number of rooms that are currently running on this process. Now, as you can tell, these processes are running in the Dallas region, but you can actually spin them up in any of these 14 regions that Hathora has support for. But the last thing I want to show is how easy it is to actually spin up these rooms in the code that I have, which I'll share the link to the code if you want to take a peek through it. So in this monorepo project, you'll see that there's a backend server. This is where the REST API lives. There's the client, which is connecting to the backend server. And there's also a session server, which is where the logic for the WebSocket server lives. I'm not going to dive through all this code because it's quite a lot, but the most important pieces are when the client wants to join a room, it is going to call this get rooms controller, which will eventually call this scheduler to get the room host. And if we scroll down, there's a Hathora scheduler, which has a create room method. And if you look at this over here, we have a this Hathora rooms v2 create room function. This is how we can create a room, which is going to spin up our WebSocket server. And you can specify one of those regions here. So I'm just hard coding it to Dallas right now. And then down here for get room host, there's a call to this.hathora rooms v2 resume room. So if this was a room that was already created in the past, it'll actually just respin it back up. And then all your users can start connecting to it and have their mouse movements and other state synced between everybody. And those are really the only 2 methods you need from the Hathora Cloud SDK TypeScript library, along with a secret key, which will spin up those WebSocket servers and allow your clients to connect to them. So the other part I want to talk about is the session server. So this is where all the WebSocket server logic lives. If I go into the source directory, there is a server, and you'll see that we basically just listen for WebSocket events, and we will spin up a room object, which is going to track all of our cursors, all of our shapes, and all of the clients who are connected to it. And as people create shapes and rotate shapes, it's basically going to send a message to this room server, and then that broadcasts it out to all the other clients who are listening for this room. So if you've built any type of Node.js multiplayer game, this is basically the same type of thing. You're going to have a stateful WebSocket server where you handle all of your game state. And then I also periodically persist it to a Postgres database as people are changing the objects. Now, the very last thing I want to point out is how easy it is to get this stuff deployed out. So if I go to my GitHub directory, there is a GitHub action that we use to basically deploy that session server to Hathora. So there's a curl command we use to basically install the Hathora CLI tool. And then you can call Hathora deploy inside your GitHub action, and you can point it to a directory. In our case, we're using that session server directory. You can say how many CPUs you want that container to use, how much memory you want it to have, and how many rooms you want it to be able to put onto your container. And then also we're specifying some environment variables that allows this container to basically reach back to my REST API for persisting state. Now, if you want to check out any of the code for this project, it'll be in the description. Here's the link right here. But ultimately, if you ever wondered how Figma achieves the scale that they do, this is the overall architecture you're going to have to implement. And I will say Hathora made this super simple out of the box, so go check them out if you ever want to make a multiplayer game or a multiplayer type feature in a web application. I've used them in the past for trying to build out a multiplayer snowball fight game. I think there's like a year or two ago on my channel. It was a lot of fun and it was actually very easy to get going with. So go check out Hathora. Other than that, have a good day and happy coding.